Welcome back, 9:38 at ease. My name Clarence with you till 12. Views and news, and of course, your calls now for the Naked Scientist. Welcome, Dr. Chris Smith. It's good to have you back. I
It's
can tell you
good
the
to talk
weather
to
in
you.
Cape Town, good to talk to you. Decidedly Londonish, dark grey and wet today after 34 degrees C Thursday. A beautiful day yesterday. That's where we
Still
are
better
today.
than what we've been having.
Yeah, I believe it's been pretty dark on your side. Okay, we're going to go straight into the questions. Question in: Can animals see color? And does the bulls or the bulls in bullfighting, do they recognize the color red?
Right. Animals have a retina very similar to our retina, which is the light sensitive sheet of tissue at the back of your eye that contains cells that can take energy and light waves and turn them into nerve activity that the brain effectively interprets as what we see. Now, what gives us our colour vision is a population of those so-called photoreceptors, which are called cones. And they're called cones because they really do look like a cone shape down the microscope. And we have three different kinds of cones. And in those cones, they have a chemical called rhodopsin, which is sensitive to different colours of light. And we have different rhodopsins which see different colours. And that's why we have three different cone types, because they see three different, essentially, colours of light. A bit like the red, green and blue that we use to build up pictures on a television screen, we have cones that see different parts of the light spectrum and respond best to them. And the way the brain works out what colours we're seeing is that it looks at how active each of those different cones are to the light that's coming in, and works out when you blend those different lights together, that's what colour you see. Now, animals have exactly the same thing, except that many of them don't have three colour cones, they have just two. So unlike our three, which means we can look at a broad repertoire of different colours and resolve the differences between colours which are quite close together in the colour spectrum, some animals can do that. Monkeys are very good at seeing particular colours, and probably because that's how they're able to choose fruits and so on that are and aren't ripe, which would make a difference to how well they can feed in the kinds of environments they live in. But other animals only have two colour cones. Cows, for example, are what we call dichromats. They only have two particular colour cones. As a result, the repertoire of colours that they can clearly resolve, and the same goes for dogs, is more limited. And so that means that they may muddle up, a bit like a colourblind person, some colours which you and I would look at them and say they're totally different colours. To some of these animals, they will look an identical colour. So if you put an object of that colour on a background of a different colour that they can't see, then they'll end up with the object disappearing. They won't be able to see the red ball on the green background, for example, because the two are viewed as the same colour to their brain. And therefore, it's a bit of a myth to say that some animals can't see certain colours. They can see all colours, but they can't resolve the differences between some colours, if that makes sense. And so a bull in the bull ring will certainly be able to see a person running around waving a red sheet, but it won't necessarily be the same red that you're seeing, because your eyes have the ability to discriminate all these different colours. They will be seeing colours that look very similar to each other despite being different to us, but they can still see the object, and they'll still see the object moving.
And is that red sheet a trigger?
Well, you could argue that you put an animal into a very stressful situation, which, being in a bull ring, is going to be an intrinsically stressful situation. You've got someone running around aggravating the animal, perhaps hurting the animal. You've got noises from the crowd, so you've got that hostile environment. This makes the animal stressed. So anything that it sees which further stresses it or is perceived by it to be a threat, which a person running around who occasionally hurts the animal and then waves something at it, this would be a threat to that animal. Of course, it's going to respond towards that object in a way that is a trigger. Yes.
Now let's go to a voice note. Joe, what have you got for us?
Hi, Clarence. I've actually got a question regarding to Chris Barnard. We spoke about him earlier in this week, and I watched some of his interviews on the internet. Very interesting. But what's actually the process of getting a new heart to start pumping in a body? Thanks. It's Ivan. I'm calling in from the Netherlands. Bye.
Thank you, Ivan, from the Netherlands. The context, Dr. Chris, is that Chris Barnard would have been 100 years old. Well, yeah, at this moment in time, 101 a little later on this year.
An amazing pioneer, and obviously look what's come in his wake. When we do a heart transplant, obviously very, very complicated surgery and needs a very skilled person. But basically what you're doing is taking a heart from a donor person, and ideally a person who is a really close genetic match. In other words, the chemical markers on the surface of the cell are almost the same between two individuals, and that can be done. You then take the heart out of the donor person and you put it into the recipient person. That's the basic premise. What do you do in practice? Well, in practice, what you've got to do is to make sure that the organ doesn't deteriorate in the time that you take it from one person and put it into the other. When you take a healthy beating heart from a donor, this is warm tissue which is burning a lot of energy, and it's actively contracting muscle, and it relies on a rich blood supply from the coronary arteries to keep that muscle supplied. So if you just took the heart straight out of a person in a hot state and then put it into a recipient person, that would be like having a massive heart attack, which happens when we block a coronary artery and we deprive the active muscle of its blood supply. And you only have to look at someone who's having or had a heart attack to know what the consequences of that can be. So what we do is prepare the person, the donor, to donate their organ. The organs are cooled down. They are fed a solution of something which slows them and then stops the heart beating because it puts the cells into a state of suspended animation at low temperature. You then transport the heart, because very often where the heart is not where the person who needs the heart is, so you've got to bring the two together, and stopping and cooling the heart puts its metabolic rate down and means it burns energy much more slowly, therefore the rate of deterioration is much slower. You then get it to where your recipient patient is. You've got them prepped and anaesthetised, and you've opened them up so that you can see their own heart. And when you know that your new incoming heart is on the way, the surgeons will already have done a lot of the preparatory work to get the person so that they've got a machine replacing their own heart for them. So their own heart is going to be removed. The machine has taken over the pumping action of the heart in the near term. You then put the new heart in, and all of the fine stitching and so on and suturing to connect the main blood vessels is done, and then the heart is rewarmed and it is flushed with a solution that that brings it back up to close to body temperature, and you flush out the things like potassium that have been put in there to stop the heart from beating and reduce its metabolic demands, and that then enables it to reanimate itself. And it sounds like a bit strange, but heart cells have their own intrinsic beating rhythm. And if you take heart cells, even from a developing embryo that's literally weeks old, and put them in a dish, they beat of their own accord. They are so-called myogenic in rhythm. The beating rhythm comes from the muscle cells themselves. So as soon as the heart comes back up to temperature and is metabolically back to normal, it will restore its own beating. And as the surgeon puts it in and begins the rewarming process, they will then watch and see that heart that they've just put in effectively come back to life and start to beat of its own accord. And once they're happy that that's happening, there are no leaks in their suturing, then they close the chest up, and the person then should make a full recovery. And the outcomes from these surgeries now are just outstanding. Not just for hearts, but for everything. I interviewed about 3 years ago, I interviewed a lady called Angela, who is now she lives in France, but she is from the UK originally. This wasn't hearts, but this was a kidney. She is in the Guinness Book of World Records for world's longest surviving kidney transplant. And a guy who trained me when I was a medical student put a kidney into her 53 years ago, and she's still going strong, enjoying her Shiraz and her Pinot when I spoke to her when she was in France, because she moved with her husband Eric to France because the weather and the wine was better. I'm sure she's absolutely right, based on our conversations. But yes, it just goes to show the power and amazing outcomes you get with transplantation surgery today.
And the beauty of life, man. Let's go to Pat in Sunningdale. Pat, you've got a question for the Naked Scientist.
Good morning, Chris. I've received a photograph of my great-grandson. He's about a year old, so he isn't speaking yet. However, he's sitting in his chair, studying with such concentration a colourful toy. He's turning it this way, that way, the other way. What language is he thinking in?
Well, when we are linguistically able, in other words, you and me, and we talk to ourselves, we're perhaps planning how we're going to do something. We often have inner speak, don't we? Your voice in your head where you have a debate with yourself. If I do that, that will happen. If I do that, that will happen. Well, one way to think about this is if you ask a blind person when they're planning on something, what do they experience? My very good friend who was blind when I grew up told me for him, dreaming and imagination was not pictures, but just words. It was speech. So, in other words, he had adapted his thought processes around the senses that he did have, not ones he didn't have, because he obviously had never seen. So a child that has yet to develop language is not going to hear inner speak, inner words, but what they are going to see in their mind's eye are actions. They're going to see, and this is part of the growing up and development process for the brain, it's uniting, when I do this, this happens. And that's what play is. And it's what sort of tickling and rough and tumble is all about. It's learning, when I do this with this stimulus, the following outcome occurs. And it's the brain teaching itself cause and effect. So him playing with a toy and looking at things, it's the brain effectively interpreting and making sense of the environment, but there's no language yet fully developed around which to hang that. But from about the age of 1, words do begin to assemble. The children are beginning to build a vocabulary. They're passively absorbing information all the time, and if you look at how adults behave in that stupid way that we behave around kids, and we're sort of talking in a daft voice, we are exaggerating things that we want them to pay attention to. So they are picking up on all of this stuff, and pretty quickly it is made sense of by the brain. And they may not be saying much, but they may well very early on, from early stages, be thinking in those sorts of sounds and already using them, but we just can't ask them.
That was a great question. Thank you, Pat, for that question. Your questions for the Naked Scientist, Dr. Chris Smith. Chris, you've told us about a kidney transplanted 53 years ago, still functioning perfectly. I think this sparked the next question. Can an organ be infinitely transplanted?
By infinitely, do they mean as in if the lady who's got that kidney then decides she wants to donate it to somebody else, could you do that? Well, the answer is it depends. The first kidney transplants were the Merrick twins, and this is a long time ago in America, and they were transplanted between them because they were genetically identical, and one had a kidney disease. His genetically identical twin brother gave him a kidney, and this enabled him to survive because his immune system couldn't tell the difference between his own diseased kidney, in immune terms, and the incoming new healthy one. So in that respect, there's no difference if you kept transplanting an organ and we assumed that you did it perfectly without any damage to the organ. In those terms, then potentially you could keep moving the organ around because it wouldn't know it was in a different body. But when we move an organ from one person to a genetically distinct person, although we try to match very closely what the cell markers are that single out an individual, it's never perfect. So there's always some degree of underlying immune response. And this is why we give people immunosuppressive medicine. And we've got much better at doing this in recent years. And the drugs we had back in history were much more brutal compared to the ones we have today. But they're not perfect. So you get some toxicity from the drug, which is a chronic sort of poisoning of all of your organs, and that can include, unfortunately, the transplanted organ. But you also get what we call low-grade rejection. The immune system does tolerate the new organ much better than it would have done in the past, but there's still a degree of slow progressive damage going on to the extent that it slowly ages that organ faster than time would naturally age the organ in its original starting person. So you couldn't keep on moving organs like that because they do deteriorate with time. Some, though, perform amazingly. And Angela's story of having the same kidney from, I think, a motorcycle victim, a motorcycle accident victim in the city of Birmingham was her donor. She's never obviously met the family, but she's aware of them. And she found that she's been absolutely fine for 53 years. There are other patients who the match is not perfect. Their immune system does still continue to build a response against the target organ, and they get infections on top. So this does slowly erode the function of the organ. So in some cases it can be a couple of decades. In some cases it can be a couple of years before that organ doesn't meet the requirements of the body anymore, and you have to look at other options.
There is a natural aging process and an expiry date.
Well, there's an accelerated aging process as well as a natural aging process in this sort of thing, because you're fiddling with nature, and as a result of that, you might reach your expiry date a bit quicker. Yes.
Gotcha. Okay, so we have a voice note in also on the topic of transplants going to the stomach. Take us there, Joe.
Hi there. Question for the doctor there is, while you're talking about heart transplants, is it possible to have a stomach transplant? Thanks, it's Clint.
The answer is yes,
Dr. Chris.
and we do in our hospital what we call multivisceral transplants. There are some people who have all kinds of disease going on in their abdomen, and it's very complicated getting all of the organs that are all wrapped up and connected together as part of your gastrointestinal system and what's in your abdomen, liver, the pancreas and so on. And so sometimes we would move all of the tissue as a block from the donor person into the recipient under those circumstances. Very, very complicated surgery, quite high risk, and so people really need to be in extremis. You need to have done a judgment and made a risk-benefit sort of judgment on, if I don't do this, what will be the outcome for that person? And if I do this, these are the risks, but despite those risks, they're still going to be better off probably. And when those conditions are fulfilled, then we would do those sorts of surgeries. So yes, it is possible to do that sort of thing. If it was just a stomach you needed, then sometimes what surgeons can do is to use a bit of bowel which they can refashion to behave like a surrogate stomach. So you can either move some of the small intestine further up into the thorax, remove the stomach that was there, and make a new stomach out of a bit of bowel that you pull up. Obviously, it doesn't have the same capacity and necessarily the same biochemistry of your own stomach, so you have to be a bit careful what you eat, and you have to be careful about how much you eat, but it can be much more convenient than not having a stomach. Or you can, as we've just been saying, sometimes get a whole new set of viscera, which you can plumb in from a generous donor.
We're going to squeeze in another question, this one via WhatsApp as well. Is Earth crust displacement likely to have occurred in the past? Grant with that question.
Well, Grant, we know for a fact that the Earth has been tectonically active throughout most of its 4,500 million year history. The Earth is interesting, and in fact there's a story in one of the major journals this week about Venus and volcanoes on Venus, and why Venus seems to behave a bit differently to the Earth despite being very similar in size and shape and composition. But the Earth is broken up into a sequence of tectonic plates, which are the continents, which are continental crust, and then oceanic plates, which is seafloor. And they have been jockeying for position and moving around for millions and millions of years. And in fact, the first evidence we got for this was a guy called Wegener, who realised that you've got islands which are formed by volcanic activity, and sometimes you see a volcano and then you'll see an island that's got an extinct volcano on it. And he said, well, if the volcano's there and the island's gone over there, this must be because the island was once there where the volcano is, and it's now moved. And that was one of the first insights into the fact that there are bits of material moving all over the Earth's surface. So the answer is yes, the Earth is tectonically active. It's always been tectonically active, and we know that because we can look at the different ages of rocks around the world, and we see a lot of young rock, but we see in some restricted parts of the Earth's surface some very, very ancient rocks, which tells us that the Earth has continuously been moving and resurfacing itself over the course of its history. South Africa, particularly around Johannesburg, has some extremely old rocks there. Western Australia also has some of the oldest rocks on Earth, some of them going back 4 billion years in some parts of Western Australia.
Wow. Okay, and that unfortunately brings the time to 2 minutes to 10 o'clock, which means we're going to have to wrap it there. Thank you, Dr. Chris Smith, the Naked Scientist, and that a weekly engagement.